Let's solve this problem LeetCode912 sort an array. So in previous video, actually, I sorted this array using kind of the quick sort. So in this video, I'm going to use merge sort to solve the same problem. Okay, so we can use a different way, but this video, I'm going to use merge sort. For the merge sort, so what's merge sort? Merge sort actually is a sorting algorithm based on the divide and conquer strategy. Oh, 1 second. Merge sort. So it's based on divide and conquer strategy. Okay, so the algorithm for merge sort. So the algorithm for the merge sort. So the step 1. So first we are going to find the middle index of the array. And step 2. We divide the array from the middle. And then step 3. We're gonna call merge sort for the first half of the array. Step 4, we're gonna call merge sort for the second half of the array. Okay, and step 5. We merge the two sorted halves into a single sorted array. Okay, so yes. So for this problem, there are gonna be two functions are involved in this algorithm. Okay, so first one, we're gonna write the merge sort function, and then we are going to merge it. This is a merge function. Okay, so for this problem, let's give an example. Let's use this example. This example 2. Let's use this one. So this one. Okay, so the index here is 0, 1, 2, 3, 4, 5. And then we are trying to find the middle of the index of the array. So the middle index of this array is 1. Okay, is 1. And divide the array from the middle. We divide from here and call the merge function for the first half, and call the merge function, the merge sort, for the second half. We are doing recursively. Okay. And then after that, we merge it. So let's just call the function. So it's gonna be, let's say it's gonna be like this. So 5, 1, 1. And then 2, 0, 0. And then what do we do? And then we do this way is 5, 1. And here is 1. And here is 2, 0. and here is 0. And then we recursively we will split this half. It's going to be 5. 1. Okay. And then this one, we're going to split 2. So here is 2. Go down away. And then gonna be 0. Okay, yeah. So this is the way we are doing kind of divide the algorithm. And then now we are going to merge it. So so here we have to pay attention, like our array when our array break down to individuals. This way I just showed you guys, and we have to notice before we start sorting. So we implement this in code, those steps we done in a different order, okay? Because we are recursively doing divide. But I do this way because this is more human-friendly order, provide more clear to learn, okay? So that means that we need to pay attention about here. 1 second. Yeah. So like before we start sorting, we need to know. So we need to know those steps we done in different order because of recursively divide. Okay. So we are doing this way just because it's pretty much easy to learn. It's easy to understand using this human friendly order provided. Okay. Okay, so let's do the merging. Okay, so merging first, we knew an array, the temporal array. So the temporal array, the length is the length of the temporal array is the same as the names. Okay, so what do we do here? The temporary. Okay, so what do we do first? So we actually compare the left and right, right? So left and right. So we can compare this one. So which one is a smaller? This is left, this is right. Yeah, the right is a smaller. So when we return, we actually write this one, the one in the temporal array, and then 5, and then copy it to here and return. Okay, so what do we do? Okay, what we do is gonna be return 1, 5 here. Okay, we're gonna return 1, 5 here, and then here. Okay, here we have a 1 directly to here. We have 1. Okay, and then for this one, we have a 2 and a 0. So we compare 2 and 0, which one's smaller? This one's smaller. So what we return is a 2, 0. Oh no, 0, 2. And then this one is directly to here. So it's gonna be like this. Okay. And then we go next line. Okay. When we do next merge, so what do we do? So we compare this left, this right. So we compare this one, which one is smaller, or which one is equal. Yeah, this one is 1, let's put this here and move the left pointer to the 5, and the right pointer is still 1, and 1 is smaller than 5, so we put 1, 5 like this. Okay, and then here when we do this left, this right, and then we compare this both, and then we know it's gonna be like this. Okay, we return this one, and then we merge again. So when we compare this left and right, and then we compare this 0, and then we move the right to here, the left is still 1. This one is smaller, so we put this one, this 0 here, and we move to 2. 2 and 1, which one smaller? 1 is smaller, so we put a 1 here. And then left is gonna be 1, 1 and 2, which one smaller? 1 is smaller. And then left gonna move to here. The left pointer is 5, and this one is 2. 2 is smaller, so and then 5. Okay, so basically, this is how it works. Okay, this is a merging function. Okay, the algorithm. Okay. Okay, this is a merging merging function. Okay, so let's talk about the term complexity. The term complexity for this problem, is gonna be big O n log n. It will be big O log n because let's see here. When we do the divide, we actually divide every single one to this one, so we can know every single level. It's gonna be O n, but we have a log n. We have log n level, so the time complexity for this part is n log n. So when we do merge, it's the same, and every single level is n, and we have log n level. So the time complexity actually is O2 n log n, and then we round it as n log n. Okay, so the space complexity. Gonna be big O n. Yeah, because we need a temporal array to save the result. Okay, yeah, it is like this. Okay, so pay attention about here. The merge sort is not an in place. It's not an in place sorting technique because it's time complexity, because it's space complexity is big O. No, it's O n. So it's O n. So which is greater than O log n. Okay. Yeah. Okay, let's start coding, okay? Okay, let's start coding. So first what do we do? We use a shared. So first we use a shared temporary array, and this is the extra memory. This one is gonna be, oh, and we just talked about this, right? This one is at least, this is at least, okay? And then what we do, we just do this. The temporal is called temp, and the new int, and then what we do, name star length. Okay, and then what we do merge sort. Okay, inside the merge sort, we will put that later, and then we return the names. Okay, after sort. Okay, there's two actually there's two function we need to write, right? So one is merge sort. Okay, so another one, no, that's the merge sort. Another one merge. Okay, so like this. Okay, let's write this one first. So the merge sort. So what we do, as we just talked about the algorithm for this merge sort. So it's merge sort. We're gonna actually recursively call. So let's see in this kind of. Okay. Oh, sorry about that. Here is wrong. Yeah, it should be like okay, here, and then we have a start, and also we have an end. Okay, it's like here. Here's the start. This is end. Okay, and then we have a temporal array. This temporal array exactly size of the exactly of a size. Yeah. And then we do. And then what we do, we just do recursively call the left part of this one. So left part of the neighbors start, middle, temp. Okay, and then we call the right portion of this one, middle plus 1 and temp. And then we merge it together. Numbers, start, middle, and temp. Okay, yeah. So another one, and then we're gonna do the merge function. So for this one, we return nothing here, void, because we just actually sort it, right? So we don't care what we return. So we don't have, I mean, like we don't have to put a return result for this function. We just sort it, okay? Int start, int middle, int end, int this one temporal, this is temporally. This temporally we have this one, and then what we do is int the left equals to start, right? So the left equal to start, then the the right is the right when we do the merging, right? The left is the start and the right is the middle plus one, because the middle is here, middle plus one is here. So so what we do, we just do this, and then what we do here is right, okay, equals to middle and plus 1 here. And then what we do here, index equals to start, okay? Index equals to start, okay? And then here, this initial, and then we're trying to merge. We're trying to merge to sorted sub array in our array in array to a temporal array. Okay, so how do we do that? Okay, so here's the code. So we write a while loop, and then the while loop, this is left smaller equals to middle, and then let's do right smaller equal to the end. So that means that we have to check the the left is smaller than or equals to the middle. If greater than middle is out of this subarray, right? So the right is the same. We have to small or equal to the end. So that's why we have to like the left and right inside the range, and then we check if the numbers left smaller than, we check this one smaller than the right. If it's smaller than the right, okay, if it's smaller than the right, so what we do, we just do this. We just do index plus plus index plus plus equals to numbers left plus plus. Okay, this is what we do. Else if. So this is what we do. Else what we do. So we can see from here, because when left is smaller than the right, we actually put the left into the temporal. The index is here. After we put it, and then left plus plus. Okay, the left plus plus to here, index plus plus 2. So waiting for us to put another one. Okay, else we put temp here, index plus plus, okay, equals to names, right, plus plus. Okay, yeah, okay, it is like this. Okay, and then after we do the while loop, after the while loop, like you know, the left or the right is already reached the end of that, and the left portion and the right portion not necessarily equal. So maybe left is longer than the right portion, or maybe right portion is longer than the left portion. So in this case, we need to do the post processing. We need to check. So we do another while loop here. If left smaller or equals to middle, then what we do, we just do continually. We just do this index plus plus and equals to numbers. Yeah, we just put the left plus plus, okay, to here. So so that means that when while the left is smaller or equals to middle, so after we stop out of this while loop, we have to check if left portion still have some element. So we check a left smaller than middle. If smaller, then we just put the left, just iterate every single element, the left, the remaining element to the index. Okay, that means the right portion is already reached the end. Okay, and then or we just or if that one okay, and then we have to check the right, the right smaller equals to end. If smaller equal to the end, then what do? We do the same. We are doing the temp and then index plus plus and equals to nambs and put the right plus plus here. Okay, yeah. And then after we do all this, so what do we do? After we do all this, what do we do? We copy. We need to copy the temp back to the array. Okay, so this part we are going to copy. We just write a for loop. So index equals to start, right? And then index smaller equals to end, and then index plus plus, and then we just do this one, index, this one equals to temp. We just write the temp index. Okay, yeah. So that means that let's iterate from the start, the temp from the start, and update the numbers index, and then we loop everything from the temporal, and then we put it here, right? Okay, let's run the code. Cannot find the merge. Okay, that's a wrong tab. Oh, here, sorry about that. We actually, yeah, here, I need to put, we need to put the element of the here. So no, we need to put the input of this one. The input is numbers. The start is 0, and the end is length minus 1. Okay, and then here has a temp. Okay, let's run the code. Okay, it's accept. Let's try another one. Let's try another case. So this one we put a 5231. Let's put this test case. Let's try it. I think it's gonna be this. Oh. Let's try it this way. Okay, let's run the code. Oh, it's also work. Okay, let's submit. Okay, our algorithm, the running time is this ms and faster than 78, almost 8% for Java Online, for sort this array. Okay, thank you for watching. I will see you next time.